presentation session one. It was great, and actually, I was impressed at the way you put it in just 15 minutes, the whole gamut of things. And thanks, Vipin, also for uh, enabling us to do this presentation, session two of the day on the NVIDIA. And my focus will be on the open source. Yet I have to start with some hardware, so I just will start with the DPUs which Farhad ended, and he had also shown some of the tables. So here you can see the traditional architecture. Generally, we have a simple NIC, that is network interface card. Instead of that, in the blue field, which is a DPU, blue field 2 I'm talking of, here you see the smart NIC being part of it. So any GPU with a NIC and all that is the difference between the traditional architecture and the blue field for the data center. So there are applications of this. Example, if you want to do in your uh, what you call in a college atmosphere, uh, the simulation, like we are doing remote work and all that. And if you want to just simulate and see how the load is distributed, then you can use one of these platforms. And this is the Omniverse for enterprise, which gives you how you can simulate things, which is what Farhad called it as Google Docs, if you remember, three-dimensional Google Docs. You can put it that way. But it's basically a simulation where you can simulate several things and see how real-time collaboration, etc., can be done. And this is the requirement, very similar to it these days. Everybody wants AI. So if you have a factory and all over places, it is distributed, then how do you do distance location, the fleets, and how do you do the security? So the fleets of servers which are all over places in global uh, for a multinational, etc. How do they do the security, and how do they use container at the edge to be able to do always on AI application with reliable and resiliency? That is what this shows. This shows the multiple remote location which I was trying to show the simulation. Now going to this, the simulation also can be done. For example, how do you design a car, or how do you actually drive the car? Those are the kinds of application you see. Why this? Just to, before we get into the open source, we need to know why are we doing all this? Why is the need for speed? So you will see that there are trillions of devices going to be there in the market, or in the globally around 2035. That means you have got it has an impact of around 17 trillion on economy by 2030. So based on that, you can see that we need a thousand x bandwidth and 10x lower latency. So it's all the game of throughput and latency, and both of them are because of the IoT, Edge AI, and the 5G. So IoT, 5G, Edge AI, all these are the four combinations which we have been seeing through in our series of lectures. So what you see here is one of the what you call simplified view of the uh, EGX stands for edge. Basically, edge. You can talk about edge. You have a DGX, EGX, RTX, and so on and so forth, which we will look at the table, which we had already looked at the table. But here is how it is. So you have the hardware is there, then you can do a bare metal, or you can do virtualize, or you can do Kubernetes, but the applications are at the top. So this is a stack of things which you stack up with the NVIDIA platform. But at the end of the day, you have to need open source. So now all these combinations of infrastructure using AI, cloud using AI, enterprise using AI, edge using AI, autonomous AI. So this is the evolution. As you see, we had infrastructure, we wanted to do AI, and not only that, we want to use AI for the infrastructure. Then we are going with the cloud. Then you see that it moved from the infrastructure AI to the cloud AI. So AI itself is in now in the cloud. Now you are seeing that it is in the enterprise. Now it's going to the edge. So we are at this fourth stage right now, and then we'll go to the fifth stage. So essentially, this evolution is nothing but more revolution rather than evolution, because in a span of just 2015 to 2021, in 6 years, you have got through 5 stages, almost 4 stages at least. So it's like a massive impact on the software itself. The hardware is changing, software is changing. Because software is changing, hardware is changing, hardware is changing because of the, so the amount of various things have occurred, and that is because of the emergence of the intelligent application as well as emerging at the edge. So you can see that intelligent retail, logistic, public service, smart cities, AR, VR. We saw AR, VR, beautiful presentation couple of days back. Then gaming is another, manufacturing, industrial IoT, traffic management. So there is plethora of applications. All of them are drawing towards a place where we need to be fast enough on the software. And software is not as evolutionary, where we have to really work hard. And this is where the AI intelligence comes into picture. So look at the stacks here. A simple platform like EGX, you have plenty of them: DGX, EGX, AGX, AGX for the automation, EGX for the edge, and DGX for the data center in on a chip architecture, DOCA they call it. So there are a lot of acronyms. Bottom line here is you can see that the amount of applications which is there shown on the right, you can see 40 million miles of road we have to cover, 12 billion acres we have to put the devices, 2 million factories are there. So all these numbers, 10 million miles of drive per year for the auto vehicles are there, 30 million stores are there, 5 million call center agents are there. So the humongous amount of things that we need to do cannot be just done by simple hardware. And therefore the GPU driven hardware is what is taking the upper, what do you call, it is taking over. Essentially you can see Nvidia is right now in semiconductor around 10th in the overall game, and Intel is at the top. I won't be surprised if this gets into somewhere middle in the in next 4 or 5 years. And it has already been the case for last 5 years. It was nowhere to somewhere, now somewhere to everywhere it will be. So we will find that GPU based computing has become important even for Intel, for AMD. Everybody wants GPU, but then first first movers advantage has always been with Nvidia. You can see that Nvidia is now uh, the stack contains Kubernetes. It has security, networking, storage all put together, and the bottom line, the that drives is nothing but Cuda. Cuda is a library. It's an abstraction which is what you call device, whatever is there, the device CPU is considered the main processor, but it is a CPU unified device architecture. So what happens is CPU has whatever it does to begin with general purpose, and then when it wants to speed up, it will give the task to the device. So device is everything in an operating system is a device other than CPU. So even a GPU, which is a processing unit, is also a device. So it is considered as a device. So you have multiple devices. So once the thread passes on from the Linux kernel to the GPU kernel, which is called also kernel, but basically it is a process running in a different device, which is in case GPU device. So as soon as it takes over, it starts doing multiprocessing. So you can have thousands of processing units, which are GPUs, working together to do tasks which can be done in parallel. So the parallel processing is what is there, and that includes the several of the libraries, 1MP, and there are many multiprocessing, multi-threaded APIs which are all used, and most of them earlier were C++. That's where the baseline is always C++. Then people ask for Python because they want simplicity. So there are something called libraries, Cython, which is C over Python, and then Cython, and over and above that, all the APIs grow. Even the one API we saw grew on top of it, data parallel C++. In case of NVIDIA, it is always CUDA and CUDA extended. So once you have the library, then you can run your various applications, frameworks. Like example, Farhad has already described all 5 of them. I am just repeating: Metropolis for the smart cities, and Metropolis for the smart retail. Then you got the Clara for the healthcare, and then you have Isaac for the robotics, and you got the 5G area for the telco, that is 5G and all that. So NGC is nothing but NVIDIA, what you call GPU Cloud. So when you have NVIDIA GPU Cloud, that is where the everybody meets, and it enables the opportunity for all of us across the industry. So this framework is everywhere same. The only thing is library may differ, whether it is EGS, DGS, AGX, all that. The libraries differ, but otherwise it is all same. And the bottom line for us is, what is open source? We are here to deal with open source, and I have given you the first thing. You must always start it always the lowest common denominator, and that is container. So if you go to NVIDIA lib NVIDIA container code, I'll click on it. You can see it. I hope I'll be able to return back. So you can see here the GPU code. So what you see is that this is NVIDIA container, and you can use this library. Just it's all available to you. You just need to use it and then move on from there. So essentially, we have got libraries of Docker. In fact, I should not have gone to container. I should have gone to Docker. So Docker is the main one. You always begin with Docker. If you can install a Docker, how to go about it? Here it is. You can see here. So you can see there is a NVIDIA GPU with multiple cores, and obviously multi-core means it is thousands of cores, not like that means it is streaming processor. Then you got the Cuda drivers. So anytime you take a, let's say you take a Ubuntu 2020, then you have to install the driver. Follow by that you have to install the Docker engine, and once you have the Docker engine, then you can if you are a simpler one, you may just have a client piece of it, CUDA client you can use, and then you can connect to the server which is there hosted on the uh, either on the data center, or you can have yourself the server as well as the client, and you can move on. So essentially, container is the bottom line. Once you have the container, then you can do everything. It starts with a container with Kubernetes plugin, a container with image processing, a container. So it is all image issue after that. You can do IoT, you can do so the bunch of things. Thrust example for very fast moving for acceleration and all. So I have given the bunch of uh, software which are open source. The issue is, even if it is open source, and if I say that you don't have a GPU, how are you going to run it? We don't have a simulator for GPU to run. So essentially, you must have minimum one of those. It could be any series. It could be Ampere, as I said. It could be a JIT. Uh, Farhad had told you all bunch of all that. So you can have any of those, and that is how we can apply. So my goal was to tell you that you have so much of hardware. At the end of it, you have got everything under GitHub under NVIDIA. All the libraries are there. Only thing is CUDA 10.x is the minimum. If you go, you will have to figure out what is the best way to do it. So open source has some limitation, and that says you have to figure out what will work with what will not work with what. Should I do Docker C 19, or should I do Docker 20? Should I do Kubernetes 1.1, or should I do Kubernetes 1.21? So the combination that works, you will have to go and figure out. That's the only difficulty. Otherwise, you got all the things that are available. As long as you have a GPU, and any GPU that works for a particular application, because all applications are different, and you have seen they are classified into different spaces, so you don't have control on it. So this is where Farhad ended it, and I will also end with here, but show you that you have got the data science applications, you got data center application, you got design and visualization, that is the simulations application, including AR, VR, and all that. You have got edge computing details which are there here. You can see like self-driven cars and industrial IoT and video library, robotics, and all that. And then you got also high performance computing, which is based on the CUDA X. CUDA is the baseline for everything and anything here, like one API was for Intel. So we have to do comparison. The comparison is very simple. At the best, I would put it, NVIDIA has got a lot of open source, and it is all available to you in the open source, in the sense that it is developed by several players, including IBM, including many players. For the Intel, obviously, they have their bunch of people joining. They are mostly following the DPC++, whereas here there is no such limitation. You go with Python. You can. Most of the people prefer Python, so this happens to have a RapidX example. Rapids is for the data processing, like instead of Hadoop, because once you have a GPU, and if you have multiple GPU, then GPU must talk to GPU. If GPU has to go through the CPU, then there is a what you call there is a conversion involved. All time, whatever you do, you need serialization, deserialization, conversion from one format to another format, then again resplitting. That is the problem. So to avoid that, that is where Farhad mentioned to you NVLink, which means that you not only go from GPU to CPU, you also go from GPU to GPU directly through a bypass mechanism, and that is the DMA, remote DMA, RDMA they call. You can have RDMA over NVMe, which are the devices which are fast. So you have to overcome not only the compute limitation, you have to overcome the IO limitation, you have to overcome the next is memory limitation, because once you speed up GPU, then memory suffers. So you need to pump up the memory. So then finally something will get. So there is a trade-off between what you can do and what you cannot do, but the optimization is a solution where you have to have multiple parameters to optimize, and that is where the whole thing boils down to. And these are the hardware platforms which he mentioned. As you can see, there is a Grace, that was the CPU he was mentioning at the end. So you got DGX, EGX, HGX, all kinds of platform. Then networking, you got the DPU, Ethernet, InfiniBand. The CPU, GPUs, GeoForce is what he started with. You saw Quadro was always there, Titan was there. So you can see embedded system, like they use Jetson, which is very popular because it is easy. And then because if it is low cost, then you can do it. So it depends on what you do, the hardware platform. Then you've got verticals, all the various CUDA, XN, Clara, and HPC, and driver, exec, and all this. So I think I will end this with this, that we have got seen application, platform, hardware, variety of things are there, and all of this learning is only possible if you go through open source, because you are not going to have that kind of resource. So research folks, I would recommend that you go with the uh, what you call the open source, which I mentioned earlier. And I'll with this I'll open the floor for Q&A. Thank you very much. Vipin, take over. I'm done. Can you hear me?
Yeah, yes. Thanks, Prakash. And
Yeah. Hi, Farhad. Glad to your presentation was super. We learned a lot from that. I would like to see your positioning of the enterprise AI, which is at the mid. Uh, you were talking something about the it can be EGX or it can be a DGX or AGX. So can you elaborate on that a bit?
I think officially the enterprise platform is the EGX. So
Oh, okay. But there is no AI has no limit. It's available everywhere. So it's a question of what you want to use, where you want to use. Correct? I got it. That's the expression you had when you
yeah,
said
there's
it
an
can be
overlap. There's an
DGX.
overlap between platforms. It's not like one platform is only meant for that. There is a slight overlap, but it's like it's safe to say the DGX is for AI, the HGX is for high performance computing as a broad categorization, but that doesn't mean that one platform cannot be used for AI or vice versa.
Correct. Got it. So we are at this stage. Where would you? I was thinking we are at the edge right now, but maybe we are at enterprise, or we are at the all three: cloud, enterprise, and edge. All three run parallelly, and some of them are mature, some of them are still maturing. Example, telco. Telco area, we need that aerial, and that has come only a year back or year and a half back, and still it is doing like example in that if you have a line rate, you deal with the line rate and the line rate encryption, decryption kind of thing. So it's not really doing at the higher level, right? In the telco, we have got stacks. If I go to PGW, SGW, I may not use it, but at the line rate is where we are doing most of the acceleration. Is my understanding correct? Maybe you can help me in the acceleration, wireline acceleration.
Yeah, I guess what you're saying
Yeah.
makes sense. Yes, most of the acceleration will happen. The whole point of this is to make the acceleration happen at the edge. Absolutely.
Super. So let me go at this one. So this is showing EGX platform. Now, how different will be EGX platform? Almost similar, or you think that will also be layered, right? But only the libraries will be different, and the hardware will be different, right?
Can you
Am I making
rephrase
sense?
your question? I don't know. Can you just rephrase
Yeah.
what do you mean by?
Okay. Okay. So stacks will be similar, except the hardware will be different. Correct?
Correct. Absolutely. I mean, if the same platform software runs, it's going to be on a different system. Correct. Yes.
Correct. Okay. That's the one I wanted to get from you. And going back, this was the blue field. You had mentioned there are blue field 2 and 3 and 200, 400 something you had mentioned. So this blue field 1, 2, 3, where are we now in the roadmap currently? I can go back maybe.
Bluefield
Uh-huh.
2 is
Yeah.
shipping. Bluefield
Mhm.
3 is for 2022, and I think Bluefield 4 is for 2024.
Yeah, I'll look at, you had mentioned something. This is the one, right? Yeah, go ahead. And
I
so,
think there's a slide on top of one before that also, the roadmap.
oh, one. Okay. No, this one. Yeah, this is at the bottom. You can see Bluefield 2 shipping 200 gigabits per
Correct. Yes.
Bluefield
And
3.
Bluefield 4 is in
So,
2024. Yeah.
so we are at this stage on the 2 only, correct? So shipping, that is 200 gigabits. So
That's
based
right.
on that, and we obviously have A10, A30, and something like that. A10, A40, and A30, A100, or something of that types. I don't know what the numbers are, but this is the one you were mentioning, right? Previously about the x86 versus. Are there any other than x86 you use in GPUs or CPUs?
Is there any CPU besides the x86?
Correct. Do you use ARM as
So,
also? Yeah.
so the
Good.
DPUs use ARM. I mean, NVIDIA and Pensando DPUs use ARM.
Mhm.
Fungible has decided to go with MIPS.
Oh, I see. So you do have, and you do support for from software point of view. Those things they are separate. Are they in the open source? Because most of the open source I find x86, but maybe it's a cross compilation probably.
Yeah,
Yeah.
it's cross compilation. And remember, these
Mhm.
CPUs inside the DPUs, for example, for
Mhm.
us, the ARMs, they are
Mhm.
mostly used for the DPU task. They are not used for compute.
Hmm. I see.
Just
Yeah,
wanted to clarify that. Yeah,
your PCI example was very good because you cannot go more than 64 with the 16 tracks, right?
with
So that
PCI
was
Gen 4,
perfect.
correct. Yeah.
Correct. Correct. Interesting. So with all this going on, uh, where do you see the data center? Especially, we are talking to the campus folks, right? We are educators and who have campus network. And if they want to do campus network, would you recommend Fleet for them with the GPUs and all? Fleet with the kind of, because campus network is, let's say 300 campuses, networks have to be connected together. Now, managing this 300 from a single point of dashboard, will it be recommended, or each one go on with their own, or there are software that can help like Fleet?
I mean,
How?
that's exactly what Fleet is for, to
Mhm.
essentially update the
Mhm.
servers in data
Mhm.
centers across vast distances. That's exactly
Mhm.
what Fleet is. I mean, there are
Mhm.
other competing packages as well from other vendors, but this will be
Mhm.
specifically for NVIDIA. So you're guaranteed that if you have NVIDIA DPUs, NVIDIA GPUs, then with Fleet, it has been tested properly.
Mhm. So yeah, it says distance with limited outside IT support. So you don't need IT support if you use this. Most of it with limited support, you can do it remotely,
Right.
everything.
You can
And plus,
do over-the-air
yeah,
updates, all that stuff. Yes.
yeah, field upgrades and all are possible. Fantastic.
Right.
Also, security seems to be pretty tight on this. You seem to have a very good security here. That's what it appears on the because you're AI based model. So you remember, I don't know, you were not there, but I and Vipin were talking to IBM folks, Animesh, and
Mhm.
he mentioned about scalable AI. So security and scalable AI are two aspects which are there in the industry. So if you look at Gartner, they talk about SaaS, that is
Mhm.
secured. So service access at secured edge, SaaS or SaaS, whatever
Right.
they
That's
call.
the Palo Alto Networks products and all that. Yes.
Correct, correct, yes.
Right.
So all that is actually encompassing here. Everything is in here. AI, edge, as well as the model for security. So this looks like an equivalent product on that terms. Uh, Automation with automation actually. Yeah. So scalable AI also is part of this. Fantastic. So that's the. So what I will say is at this time, uh, uh, tell us something which you think we should know better than. Obviously, you do have your limitations, but you can share with us what you have seen in the open source, where you have to support a lot of people. How do you go about it? What is your approach to that? A lot of sources, right? Open sources. So take some of the instances how you do your work. What is your day in work life? Let's say, put it that way.
Well, so I'm basically administering NVIDIA's main cloud. It's primarily
Hmm.
for internal development. So we
Hmm.
have, whenever a new card comes in, for example, right now it's Ampere 30XX series, there's proof of
Hmm.
concept, there's the firmware guys. Once the card is running, it has to be tested for different apps. All these um, platform software, it has to be put inside different systems. It has to be tested with different platform software, different SDKs. In addition, we have different NVIDIA teams working on simulations, for example, Range Rover simulation that just landed on Mars. So we have a wide range of developers working on it. We also have, at least the platform that I manage also has a small amount of external traffic coming directly into our cloud.
Hmm.
So my job is mostly keeping our cloud. We are the second biggest bare metal OpenStack bare metal cloud in the world after CERN.
Wow.
So we have about 9,000 bare metal servers running on OpenStack Ironic, and that's basically under my responsibility.
Wow. So you do so Ionic. If you are doing, then you must be doing also Kubernetes, Metal Cube, and all that. Are they usable under with Red Hat, Metal Cube, or something of that kind, where you do, or your own management tools are there?
Virtualized GPU is just beginning to take off. I mean, for the
Hmm.
most part, even though I mean there's a lot of hype around it, virtualized GPU is just about taking off. I mean, for the most part, we still have bare
Hmm.
metal nodes needed for our GPU, at least for our internal development right now.
Hmm.
There might
I
be,
see.
that being said, there might be other groups working on virtualized
Hmm.
GPU, trying to get uh, GPUs working with Kubernetes and all that stuff. But
Hmm.
that's not what right now I'm.
Hmm.
It's not under my responsibility right now.
Sure, sure. So, but you see, OpenStack is still going great guns. There is no running away from it with vGPUs and all that.
Well, we've done multiple analysis on what's a better platform. I mean,
Hmm.
we've I mean OpenStack comes with its own set of issues, as you know pretty well. I
Correct,
mean, you
correct,
can't get the reliability that Kubernetes gives you. But
correct.
for the platform, for our requirements, especially for bare metal, we couldn't find any better alternative, especially the fact that
Mhm,
we need VMs and we need bare metals. We just couldn't find a product better than
mhm.
what we are using, OpenStack Ironic with Nova and all that stuff right now.
So is the OpenStack still you use the train version or you are in the latest version?
We are on Usuri. We are on Usuri now. Actually,
Okay.
OpenStack's working
Mhm.
on Wallaby. So V is also
Oh,
out, Victoria is also out, and right now
mhm.
the community is working on Wallaby W release.
Correct. Correct. So you do go with the latest and the greatest, and it works. Ionic at least works for you because that's the
Yeah, I
key,
mean,
right?
for the longest time we were on Queen's release, but now
Okay.
Queen's doesn't have the concept of conductor groups, which is you can map the bare metal nodes
Mhm.
statically to a particular thing, and that's the feature we really wanted, because one of the
Mhm.
features is uh, how we can run bare metal nodes outside the data center. So that's one
Mhm.
of the features that we could use conductor groups, which is a feature that's offered in Usuri.
Usuri, okay. So Usuri is the default at this time. Yeah, that's fair enough because you are already on top because not much away from, right? Xena is the one currently being produced, which will come out in probably uh, November types. So WX, UV, WX, so 4 will be supported. So this Usuri will be supported for another 6 months down the lane, or more than that, even 12 months. So you have a life of 1 year with that, you can continue as. Essentially, that's
Correct.
good.
Yeah. I
So
mean, the
you
other
have,
issue is, remember, we are all running on CentOS, and CentOS official support is going to be removed by Red
okay.
Hat. So we are waiting to see what happens after that, which OpenSys vendor, which OpenStack vendor picks it up, that kind of stuff.
So Ubuntu 20.20 is 20.04 LTS is what I heard is we are at least seeing in the continuation.
Hmm.
And CentOS 7 will be definitely be taken off. So that's what I was
Eight.
trying to look into the
CentOS 8 is already out, so we're on
correct.
CentOS 8. Yeah. So even, I mean, once that Red Hat stops supporting CentOS, we'll
Mhm.
have to see who's picking up the CentOS effort. So
Oh, okay. You don't plan to change anything CentOS, but you can still give it on the Ubuntu, right? Ubuntu is available 20 or no? You do have support for 20, right? I have to see. I did not note it. Okay, but NVIDIA Docker is there anyway. Why worry? You can run it on anything, correct? Is there a limitation on that? If I take a
well, as
Docker,
you know, with in theory, OpenStack should be rock solid. So in theory, a lot of things are supposed to work
Mhm.
and be rock solid. But when you really start scaling out, that's when problems happen. So we
Okay,
need something that's not experimental. I mean, it's not something we are doing with a proof of concept. It's a full production network. So
correct, correct. I get it. So basically, some vendor has to step into. So there is a vacuum available right now. If somebody can pick up the CentOS,
yeah,
and
I mean, I'm sure.
there was one company I believe in EU, which Europe, which started working on I think UK, one of the companies, but I did not follow. Maybe we can do offline
Sure.
these questions we can answer. All at the end of it, I would like to give you the open floor. Tell us what you think going down. Anything about future? Anything you see? Something which
I mean, I can
especially.
just, I'll just repeat essentially the substance of what our CEO said. I
Mhm,
mean, the data center is going through a massive transition. Uh,
mhm,
as I repeated earlier, that it's gone from monolithic to microservices based with the GPU for AI machine learning applications, and finally to DPUs. We are no longer, we will no longer the term data center as the central is the central unit of computing. That's something that is gonna come true in the very near future. We cannot individually look at, hey, this is one microservice, it's sending traffic from here to here, all those days are gone. We have to, the way the scale and the complexity of the problems that we are trying to solve, we have to look at the data center as a single unit of computing. I think our CEO's vision is in the right direction.
okay.
Yeah, and
Looks.
that's
Uh,
yeah.
go ahead, Vipin. Yeah, I'm done. You can.
And thanks Farhad for sharing such a knowledgeable session with our participants. We
That's it.
extend our heartfelt thanks to you, Farhad, for taking out time, and we really hope to have more engagements with you in the future. And with this note, thank you, Farhad. Thank you so much.
Thanks, Vipin. Thanks, Prakash. Appreciate
Hey,
it.
thanks everyone. I appreciate.